Hi there, this is going to be the second video about the bisection method. I've made another one as a very first one about this method, which I basically explain everything, step by step, going into details. So basically strongly suggest you to say it since it's the very first one. But if you have already seen it and you are here for the second example, well, here we go. Let's see that we have a function. I don't know, something like, well, we can start with the same function. We can do something different, like, I don't know, um, like this. X to the third minus 2 equal to 0. Okay, so this is basically going to be our function. Okay. And as I basically said, our function has to be continuous and we need two starting point. The very first one has to be positive or negative, and the second one has to be opposite. So it has to be positive or negative, but they have to be opposite. So we need one starting point and the second starting point, and those two have to be opposite. So one positive and the other one negative. So as a starting point here, we're gonna choose, I don't know, x1 equal to 1 and x2 equal to 2. So our first point is going to be 1 and the second point is going to be 2. So let's see, f of 1 will be, we're basically plugging the value into our function. 1 cube minus 2, well, this is going to be 1 minus 2, which is negative 1. So our first point is negative. Let's see, f of 2, well, f of 2 is 2 cubed minus 2 is going to give us 8 minus 2, so 6. There we go. So one of them is negative and the other one is positive. So if we draw our, sketch, oops, bad line, well, my bad. So if we draw our sketch for this function, we're basically going to have, well, this 0, so our first point 1 and our second point 2. So at 2, the function goes up to 6, so it's going to be here, and at 1 the function is negative, so negative 1, so there we go, negative 1. So we basically have 2 points, one positive and one negative, and since the function is continuous, we know that it's going to cross the axis. So the question is, where is it going to cross the axis? Well, let's find out. We have a negative value and a positive value, so our next guess is going to be that it's going to go through here somewhere. So we're basically going to do xr1. Our xr1 is 1 plus 2, so our 2 points divided by 2, so the middle point is going to be 3 over 2, so 1.5. There we go, 1.5. And now we're basically going to plug 1.5 back into our function and see whether the value we're going to get is positive or negative. Okay, so f of 1.5 is actually going to be, well, 1.5 cube minus 2 equal to 0. Well, this is actually going to give us 3.37 minus 2, so 1.37. So there we go. And 1.5, the function is positive. So let's see, 1.37, so 1.5, there we go. So it's basically gonna pass through here. So now there is no way, in the former example, we basically went, from here to here, from here to here, from here to here, and so on. But right now, there is no point in doing, the middle point between 1.5 and 2, because it's going to give us, a point somewhere here. So between this one and this one, those ones are already positive, and we want to know where it crosses the axis. So we're gonna look for another value between 1 and 1.5. So between here and here, because we expect it to cross the axis somewhere between here and here. So basically here. So let's see. XR2. So our second guess is going to be between 1 and 1.5. So 1 plus 1.5 over 2. So everything divided by 2. And it's actually going to give us 1.25. So let's plug back in 1.25 into our function. So f of 1.25. So 1.25 cube minus 2 is going to give us 1.95 minus 2, so negative 0.05. So negative 0.05, so it's still negative, but negative 0.05 it's very, very little value, so it's very close to 0. So let's see, this is 1.25, as we said, and the value would be, I don't know, like here, negative 0.05. So it will be like going through here. So our best guess for the function will be, well, basically this curve here. There we go. So this is how we expect this function to be. And this is basically the bisection method. And of course, the method, as I said, is going to converge. And going on, it will be trying a point between 1.25 and 1.5 and so on, finding a closer and closer approximation and a closer value to where it's actually going to cross the axis. But 0.05 is really close to 0, so it's a pretty good approximation. All right, I hope it helps as always, and I'm gonna be doing another example, so see you soon.